you all can hear me, Russ. Russell, you have done a really yeoman's job of holding down the fort for all of us. Um, this is not how it was supposed to work out, but here we are. And I think that I know that we have a lot of really interesting things to talk about. When I initially was thinking about this panel, what I wanted us to be, one of the things that people talk about is when I talk about open source, and I'm kind of a little flustered here with where are we? So I'm the executive director of LF Energy, and LF Energy is a really big supporter of Z Prime. Really sorry that I am not there. That's not how it was supposed to be. And if you guys even pulled the camera out even more, it would be great to kind of see who is in the room or how many people are in the room. I have absolutely no idea who I'm talking to or what's happening. But when we talked about what kind of a panel to do, one of the biggest questions that I get is when people don't know much about open source is they say, well, yeah, but it's not secure. And so what I wanted to do is take the conversation of security back a couple of 100 feet and to really talk about what does it mean to actually be designing software environments from cradle to grave or even conception to grave and a secure by design. So towards that end, I started to think about who would be best to sit on a panel with us. And I came up with 3 really great folks who have a lot to say and who are really speaking from 3 very different positions. John Muir is talking about it from the position of LCRA as a utility, water and electricity utility that is local to the Austin area. Brian Malindorf is talking about security from the open source OSSF, which is the open source, no, I am losing it here, the Secure Software Foundation, Open Secure Software Foundation. And it really knows a lot about security and is really on the edge right now of really trying to take the conversation around software design all the way up to the White House so that we actually can create a safer, secure, more secure software supply chain. And then Russell Blair is from Dell. And so he is in the hardware space. And he is, they are looking at it not only making sure that all the chips that are embedded have unique IDs, but that actually that there's a bill of materials for every single piece of hardware that gets created. And when you begin to put all those things together, I think we begin to see what it actually takes to build a secure software supply chain. So I'm going to stop there, and then I'm going to pass it around and kind of let everybody introduce themselves for a couple of minutes. And I'm going to do it on my screen from John to Brian to Russell.
John?
Sorry, I was muted there. So I'll go next. My name is John Muir. I'm the Chief Administrative Officer at LCRA. If you're from Austin, then you probably know LCRA as a wholesale water and power utility that's based in Austin and serves several million people from the Austin area up through a few hours west of Austin, all the way out to the Gulf of Mexico to Matagorda Bay. So we are a pretty diversified utility, all on the wholesale side. So power generation, electric transmission, wholesale water to a number of those facilities. We also operate a number of parks and do other community service type projects as well. So my role at LCRA is to oversee a lot of our shared operational functions, and 2 of those that I'll talk a lot about today are what we call digital services, which is our IT function and a number of our shared OT functions as well. And then our cybersecurity team, which is something we've really invested in and grown a lot over the past 8 years since I joined LCRA. And I'm really glad Julie invited me to be part of the panel today. Cybersecurity is so critical, and making your systems secure by design is really the way that we will actually safeguard all of the amazing benefits that technology offers us for digitalization and for the grid of the future. So all of these things, these great things we're looking for, renewables integration, better demand response, better just across the board, the computerization and the application of computers across the entire grid is only possible if security is ensured. If security is not ensured, then all of those great dreams, all of those great opportunities can't be made a reality. So I'm definitely glad to be part of this conversation today. And we'll say at the outset, as Julie mentioned, open source, that to me, the way I look at it, there are secure practices and insecure practices. And then there's open source and closed source, and those are two totally different things. You can have insecure closed source software, and you can have secure closed source software. You can have insecure open source software, and you can have very secure open source software. So for me, it's a question of finding what practices and principles are in place, what tools are either being used by my team or embedded in the tools they're using, and what are the security protocols for those tools, and that's really how we make our decisions in that area. So it's good to be with you. I'll go next.
Thank you, Sean.
Julie.
Absolutely. Brian?
Great. Well, it's really great to be here, although I wish I was there in Austin. We were talking about barbecue earlier. So I'm Brian Malindorf. I'm General Manager for the Open Source Security Foundation. Julie, you were close. It's all good. Which is just like LF Energy and other Linux Foundation projects, part of this large Linux Foundation family. And it was started when there was a set of organizations who realized that there were some ways in which open source software, the open source ecosystem was building code that were perhaps not optimal and were leading to potential surprises. I mean, going back to the Heartbleed attack, where this little tiny component called OpenSSL, everywhere it's embedded, maintained in volunteer time, kind of in off hours by two guys named Steve, and yet was the basis for all of the security. No offense to people named Steve in the audience, but it was the basis for all of basically the security of the internet. Every TLS connection depended upon this tiny library that was being under-resourced. And particularly in the last few years, we've started to see new attacks on not just on open source code that is under-maintained. We've seen attacks that sometimes come from open source maintainers who are kind of lone gunmen, working on, again, a tiny piece that gets included everywhere. This is the colors.js, faker.js thing, if any of you are familiar with that attack, to other kinds of attacks that are still attacks by third parties on, login credentials. A lot of sites still don't require developers to use multi-factor auth, for example, to publish new software updates, to typo squatting, where you're a developer, you include the name of a package, you get a little off by one, and somebody's registered a different package that does almost the same thing. It's just that they embedded a cryptocurrency miner in it, right? So there's all these new kinds of attacks that the open source community is well prepared to be able to mitigate, but hasn't really organized itself in a way to address that, and is fighting certain other trends. Just as by way of example, the popular Kubernetes cloud platform includes 8,000 different tiny dependencies into its aggregate. Some of those dependencies are projects with proper teams that do security checks and all those kinds of things, but some of them, frankly, are 100-line modules written by one person who, you hope got things right. And overall, there's some good security practices. But even in the atomic, there's still the risk of a CVE popping up like Log4j that suddenly we realize, is so easy to exploit, and we're all scrambling now to face. So how do we address those? That's what the Open Source Security Foundation has been organized to try to do, is to look holistically at the supply chain, to think about it as the bridges and highways of modern society as critical infrastructure, And what would you do to help people building critical infrastructure make smarter choices about the open source components that they select to bring in? Things like the Linux kernel and the Linux operating system, which has funded security teams constantly looking for holes, constantly looking for new ways to get it attacked, and then patching those quickly and pushing out updates. How do you steer people towards those kinds of well-run projects and put some red flags around some of the ones that might be more innovative, might have some cool new features, but don't yet have the maturity that you really want to see inside of software that runs the electrical grid. But then also using those kinds of tools to figure out where might investment into some of the younger, more innovative, more interesting code that is starting to get adopted actually go and reduce that from a red flag to a yellow flag to maybe ultimately a green flag and reduce everyone's risk collectively. Lots of different aspects to it. I don't want to abuse the intro to get into, but we are really trying to face what I think is actually not just some people don't believe open source software can be secure. Okay, we've got to help answer and understand where that happens. And just like John said, you can it's kind of an orthogonal thing. But really, I think we have just as much risk from an irrational exuberance around the security of open source code, where we might believe this stuff is just by virtue of being open source secure. And we know that that's not true either. So our goal is to provide tooling, guidance, dashboards, education, all sorts of different approaches to making the open source ecosystem more secure by default. And that's something I'd love to collaborate with the energy industry on.
Great, thank you, Brian. And I apologize for getting the name wrong. Russell, the man on the ground who is holding the fort down.
Thanks, Julie.
Take your spin. Tell us about energy and Dell.
So I'm the Global Energy Field Director with Dell Technology. We have a global energy practice. I focus on our utility practice. And we've had a cyber resiliency initiative for the last several years. According to our research, and a lot of utilities are the second largest industry that's targeted right after the financial system. And we've been really working on from a hardware and a manufacturing perspective, ensuring a complete, a trusted supply chain to be able to deliver all of our products to all of our customers in a secure fashion. But then also we have, for example, federal customers that have very specific requirements as far as where you can source all of the components. We have all these processes to put in place as far as secure verification of every single component in the device to make sure that it meets all of the cybersecurity and compliance requirements. So that's really more what I would say from a physical perspective. I mean, we've got some initiatives that started during the pandemic around making sure that when your device, whether it's a laptop or a server or storage, it has been untampered with. That was something that was a request during the pandemic. Then also we, from a software perspective, we're responsible for the firmware and the BIOS in the operating system, in the system. And so what we also worked really hard on is being able to provide secure, they call it trusted platform modules, to be able to ensure that the device itself has not been compromised from a firmware. I think one of the stats that I read, something like, I think 50%, I think was the number of industries have had some type of cyber attack in the last 12 months. So it's, and that is continuing to grow. And Dell is committed from an infrastructure perspective of not only providing the hardware, but the software and also services to help our customers to ensure their cyber recovery goals. So, thank you.
Thank you, Russell. So I'm going to kind of set the table, and then I have a series of questions. And I really respect y'all in the audience for sticking with us. We're trying something new. So, digitalization is not an option. When we look at what the power system networks of the future are going to look like, they're going to be, networks of billions of devices that are, that are possibly loads, but they also could be resources. So at the heart of this, really, communication is going to be software, and that's what we're trying to talk about. When, John, when you as a utility are looking at digitization of the grid, how do you organize yourself as a utility to really meet the digitalization requirements? And how do you see that, and how does it play into your vision?
Sure. So we really see. So I'll give you kind of two main points of how we see that playing out at LCRA, and I think this is a good model for utilities in general. So, and the two pieces I'll mention is, one is, where is the technology investment, and then where is the cybersecurity oversight and action. So for technology investment, utilities have always had some sort of centralized IT department. What we're seeing is certainly that continues managing your information technology, but more and more your IT departments are being called upon to manage things that were traditionally OT, or operational technology. And the reason is because more and more operational technology is using techniques and technologies that your IT folks are familiar with, like IP-based networks, computer systems, routers, servers, Ethernet cables, software, you name it. And so the same transition we saw years ago with voice over IP, moving from a telecom device to basically an IP network device, is happening around utilities. So we're seeing an expansion of the role of that central IT group to take on some digitization, that you're not going to centralize all of it, that digitization and technology is going to pop up all over your business. It's going to be in your transmission team, it's going to be in your power plants. It may even be things that your individual workers just buy on their own and bring in as their own devices. So technology we're seeing springing up everywhere, and that's okay. And so we have that centralized group that sets standards and operates a lot of things, but also kind of pulls, allows a lot of flowers to bloom around the organization. From a cyber standpoint, I think it's sort of the opposite. It's very important that your cyber folks are centralized, and that it's clear from your board to your management team to the folks on the ground that your cyber team has the jurisdiction to secure and to guide the securing of all technology that happens in your organization, whether it's done by your central group or whether it's done by a business unit. There are a lot of utilities where they don't even claim that in theory, and a lot of them that claim it in theory and don't do it in practice, and they basically let the quote-unquote cyber folks worry about the IT guys. Well, if you're digitizing a power plant, the IT guy, breaking into your payroll system is not as bad as breaking into your power plant. So your cyber folks really need to have visibility and jurisdiction, if you will, and be empowered to make sure that everything, whether it's brought in by an individual employee or a business unit or your kind of mainline technology groups, has been secured.
That's great. That's a great answer. So, to build on that, Brian, given the dynamic nature of, that we are in this rapidly evolving power system, how do we design the software supply chain, from your perspective, from conception to grave, to make it trustworthy and secure? And of course, saying this in a couple of minutes, it's not going to be the last thing you're going to say, but get us going with how to think about that.
Yeah, so the software supply chain can be thought of as the sequence that goes from developers writing code to working with other people jointly on that and putting it together into some sort of package. Generally speaking, that software sits on top of underlying dependencies, whether it's a particular operating system or library or platform, and then packaging that up and shipping it out to either through a distribution site or directly to a customer, right? And at many places in there are opportunities for compromise. Really the only good defense against this is a mixture of education of the developers on how to avoid some of these common pitfalls. And this is education such as we've published at the Open Source Security Foundation around secure software development fundamentals. It also does come down to being very thoughtful about your underlying dependencies. Now, you can trust that if you're building on top of like a Linux operating system, frankly, at the operating system level, this isn't the problem. I'm talking about when you are choosing this bespoke, tiny open source dependency you found on GitHub somewhere that has a few motivated developers behind it. Sounds really cool. Your developers pull that in and they go, great, we're going to use this, and it gets us so much further ahead. You might want to look for a set of characteristics like, does that project follow what are called, has it achieved something called the best practices badge? This is something the OpenSSF published as kind of a checklist for projects to follow with really some basics, some basic processes. Do you have a security team? Do you have a published coordinated vulnerability guide, right? Do you have a published vulnerability disclosure process so that your users know how you'll deal with a log4j kind of scenario, right? So there's a bunch of other attributes you can look at that really are on the developers to look at when they're choosing what code to bring in and then pushing out to their own through their own downstream. Further downstream, there's two technologies in particular that we're starting to see adoption of. One is a signature approach called SigStore. Distribution of software in the supply chain has tended to be very informal, except putting aside like Apple App Store and the Google Play Store and those kinds of things. Generally speaking, people would pull things off of GitHub or other open source sites, combine it in and ship it out. And that's always been a risk because compromise of build systems, compromise of repositories. So what SigStore adds is a signature layer, meaning every software component, every artifact can get signed by the developers who publish it, mostly through automated tooling, but in a way that is lightweight, in the same way that Let's Encrypt brought digital keys to and really helped encrypt the entirety of the web, right? Made it really easy to get keys for your SSL or your TLS-based website. Likewise, SigStore makes it easy for developers to get these kind of ephemeral keys to sign these things that get shipped out, and for people to validate that these truly came from the people I think they came from. And then building on that is another technology called SLSA, S-L-S-A, which is a set of specs and now software for being able to describe what level of assurance are you providing around this individual component. And then as that gets aggregated with other pieces, help me understand the overall risk profile of this application that I'm about to deploy. This was actually software that was built originally inside of Google to manage their own internal workflows around software to production and to be able to judge risk. Because you can't always say, we'll have zero risk. Sometimes you have to take risks to be innovative, but you can be much more scientific about calibrating the degree of risk you're willing to take and then figuring out where can I act to reduce that risk. So SLSA really helps with that, SLSA. These are just a few of these pieces. The most important thing in the short term is developer education, just going back to that. People, especially developers, generally speaking, are self-taught. We have computer science programs out there and the like, but most developers learn through reading O'Reilly books or reading the man pages or those sorts of things, and rarely do they get a formal education in software security, let alone even an informal kind of thing. The 20 hours of courseware we've put up, we're hoping becomes sort of a standard in the open source community for being able to mitigate the risk of a future Log4j. In fact, had the Log4j developers taken that course, they would have seen that this one lessons very specifically about trusting user-provided input, and perhaps have avoided the Log4j, Log4Shell debacle that we saw. So, anyways, those are just some basics to that, and that really speaks to how software is built and deployed. Lots more directions we can go in with that, but it has to start with that.
It's great. I think that this is so important. I mean, each of our projects within LF Energy does badge, and they've been advancing along, which is really terrific to see. It's been a maturity thing because the developers were just developers. They didn't know about community. They didn't know about these things, and so really walking them through kind of a capacity building has been so incredibly important. And then you didn't mention anything about software bill of materials or its role
No, you're right. In fact, I should mention White House Executive Order 14028, published last year in May, was partly a recognition of the fact that as federal government deployments, no one knows what's running underneath the covers. No one really has a good sense. There's no product labeling law out there, but there are approaches to trying to figure out, given this piece of software, this black box, what's inside. One of those is simply using a software bill of materials approach, just like looking at a ketchup bottle and knowing what the ingredients are and other analysis of it. So that executive order said, we got to do this, our vendors got to do this, and starting by August of 2022, which is coming up, software delivered to the federal government must publish a software bill of materials of the pieces that are inside, hopefully meaning that the next time Log4j kits there'll be a more straightforward process to figuring out where that is running, which is the first part of figuring out how to remediate it. Of course, that's just a piece of a very large picture, but thank you for my oversight. SBOMs are an important part of where I see this heading in the long term.
Yeah. Every single one of our projects, once they get out of sandbox and they go into incubation, they all have clean SBOMs, and that's been a real process for us as a community. So, Russell, as technologists in the energy industry, how should we be thinking about cybersecurity and how it evolves when we look at hardware and software technologies together and the architectures we need to help accelerate the energy transition?
Thanks, Julie. So the way we approach it at Dell is we have a term called intrinsic security. So you look at your entire supply chain and figure out what your vulnerabilities would be. You do your assessments, and then you try to ensure that intrinsic security throughout the supply chain from the time that you design all of the components to the time that it's delivered to the customer. The other is, and when you put together the architecture, the other concept is called zero trust architecture. So basically you always trust but verify, you always verify every communication within that architecture. And those are just like, I would say not conceptual, but approaches as far as, and then specifically within Dell, what we've been trying to do is to create value-added frameworks to help the utilities to ensure that they can meet the cybersecurity requirements and their compliance requirements. So for example, we have a framework that we've worked with VMware on that meets the NIST 853 requirement, and that framework is that you can overlay that on our architecture. So think of it like this, that we can provide a framework to help you to ensure your cybersecurity requirements from the application down. So we don't provide the application itself, but we can provide all the underlying infrastructure. And we've been working to automate that, the deployment of that framework. But we've also been working specifically by verticals to extend that. So for example, for NERC SIP requirements within the utility industry, we've identifying all the control points in that architecture, putting it in a database and being able to provide that framework to our customers. So think of it as, instead of us delivering just a piece of commodity hardware, that we can take the, the virtualization software, the hardware, and provide the underlying framework to ensure compliance and security for everything below the application. I think we lost her.
Julie, you're on mute.
What I said was, we really have to get this right. There are so many moving pieces. And as always, it really comes down to people. And, who are coming from really different perspectives. And, Brian, I know that you have a really hard stop. So I'm going to pass this to you first, and then to John, and then to Russell, and then we'll wrap, because I know you're going to have to drop off. So how do we help people who are coming from really different perspectives, business executives, procurement departments, on-the-ground developers, and how do we help them get aligned? How do we help them make better decisions?
Well, that's been the question of the day when it comes to how to mitigate breaches and the like. I harken back to when I started working at the White House in 2009 in the Office of Science and Tech Policy. I came in as part of the Obama administration, having worked on the campaign. And at that point, the federal government had basically purged itself of technologists. The premise was technologists need to live at contractors, at vendors, let them respond to our RFPs. But otherwise, don't let them in the house because, they're just nerds. What do they know about policy or about governance, right? And the fact is, that guarantees that you'll never be a smart consumer of technology and never be thoughtful about the policies you set up that are geared towards striking the right balance between innovation and robustness. And over time, certainly with the healthcare.gov kind of thing, if anyone recalls that in the room, there was a real pivot towards recognizing that technologists and policymakers and operations folks and business line of business leaders can work together and need to work together on common on solving this problem together. And so I would just encourage folks in the room to not be dismissive of your technology teams. And if any of you view yourselves as, well, we're not a technology company, I hate to use the aphorism, software is eating the world, but software is certainly very hungry. And everybody out there is a technology company, whether you realize it or not. So I wish I had something more specific than that topic, but there you go.
That's great. Thank you, Brian. And I will see you again sometime soon. Thank you very much. It's so true that software is eating the world. I don't know if any of you saw actually the assessment report from the IPCC last week. One of the 6 pillars that it talked about that are leverage points for kind of mitigation and acceleration of decarbonization is, in fact, digitalization. And the first principle was about governance. And so this idea about governance is something that not only, which I think of as secret sauce of the Linux Foundation, is how do you create communities of governance with all stakeholders. But that governance, my background is working in corporate governance and is in working in multinational companies that are, looking across multiple different domains and how we actually govern ourselves. So how does LCRA consider cybersecurity and the acquisition of software and hardware when you look at your supply chain? And are there any kind of secret tips that you found or superpowers you found that make you agile and able to move quickly? Because we all are going to have to become technology companies because we have to move at the speed of the urgency facing us. So how do you do that? What is your governance model?
Sure. So one of the roles that we created within our cybersecurity team is called cybersecurity business integration. And the purpose of that role is to help not just us do cybersecurity ourselves, but to help us integrate cybersecurity into the way other parts of the organization works. And supply chain is not any different from that. So for us, when we look at our supply chain group, what we needed to do was partner with them to understand their policies, procedures, how do they do their job? How do people make decisions around technology? And then where are those leverage points that we can insert, an efficient but effective check in the process that gets cybersecurity engaged in a way that's appropriate for us but doesn't slow them down. And what we found was there really was 2 points in the process that had the most leverage. First is right off the bat. So when we're buying any piece of technology, the first thing that gets looked at as the initial conversations are starting, even before proposals are fully evaluated, is do they meet a reasonable minimum set of standards? If they don't, they just don't make it any further than that. And so, and they can commit to meeting them, and that'll let them get into that next round. But there's kind of an initial stage, and in a sense, this helps the team to say, look, if somebody's too far off the map, they just don't do cybersecurity right, let's not waste our time with the details of reading 300 pages of a proposal. We don't need to, and that actually saves the team time. The other piece that we'll do is to come in at the end and validate that happen in practice. And what we've found is a fairly kind of surgical strike at those 2 points really gets us engaged in that process without slowing them down or fighting with any of these other, kind of steps in the process. And so it kind of keeps the internal customers from getting attached to something before we know they do the basics right, and then does that final check to make sure that nobody kind of misses something before you ink that contract. Oh, you're on mute there, sorry.
That's great. I actually I love it that you basically have a gating factor to even reading the rest of the proposal, which is it secure? And what are their security practices? Because we really have to up level here. So Russell, how would you, as a corporate, as a partner, as a hardware services, the way you actually end up in a utility, and you're working all the way from desktops to data centers to out in the field and IoT devices and substations. How do you work with your stakeholders in a way to really enable and facilitate executives, procurement, and on-the-ground developers to be working together successfully?
So the way I like to think about it, and this is just what I'm going to leave you, is that we focus so much on prevention and detection that from my perspective, especially in the utility, it's time to start working on recovery and putting more. It's not a matter of if it's going to happen; it's just a matter of when it's going to happen. And so what I've started doing is kind of shifting my focus from a utility industry on recovery. And now we are going to do everything we can to prevent, a cyber attack, but then also make sure that we've done everything possible, but recognize that one of the limitations, especially on the software side, is that there's updates that need to be made to the software, and there's always going to be vulnerabilities that are going to be found at some point. So one of the things that we're doing at Dell is making sure that we can either deliver pre-tested or pre-validated software, and we can do it in an automated fashion to be able to keep up with all of those various patches and updates and get that automatically deployed out into the field, especially, for example, at the edge and more vulnerable places. What I've learned is from working with the utilities is that the challenge is the utilities, especially with the digitization of a lot of equipment and a lot of assets, is that they are very limited in the amount of resources, time, money, etc., to be able to maintain and keep all of those assets at the current levels that they need to be, and that's a vulnerability. That's unfortunately just a limitation that we're living under, and so we're always trying to figure out how we can deliver the automation and deploy those updates in a more timely fashion, and anything that we can do to add value to that process through our tool sets. That's what we're focused on.
That's great. As we are moving rapidly toward software-defined infrastructure. There's some of it that's beginning to emerge, but that software-defined infrastructure is going to be critical, that the hardware and the software work together to really create a cyber secure and secure by design environment. So we are over. We started late, but I want to make sure that we each have a little bit of time to make kind of a call to action, closing from kind of your perspective and where you sit in the room. And I'd love to hear from both of you.
Sure, I'll kind of make one last thought and then hand it to you, Russell, since you're in the room to close us out. So I think, thank you, Sheely, for putting this panel together, and everyone for soldiering on through all the challenges we've had. I think my final thought would be not to give up on the idea that all of this can be secured. I think that when we look at cybersecurity, it is a daunting task. Russell's exactly right that no system is unbreakable, just like no physical protection systems unbreakable. So things will happen, hacks will happen, recoveries will be needed. But this can be done. The new technologies that need to be applied to digitize the grid will be developed, and they can be developed in a secure way. And more of our infrastructure can become so much more effective, so much more valuable, so much more clean, reliable, and low cost than it's ever been before through the application of smarter technology throughout the process. So I'm glad to be part of the conversation. And my last thought would be, let's go invent this together. Don't give up.
My final thought is I think the key is really about creating communities, especially around cyber recovery. I think the fact that it's accelerated, especially in the last few years, it's about being able to be transparent and providing that information to the industry and being able to quickly deploy those remediation out in the field. I think that's the key from my perspective.
Thank you both, and thank the audience for being such hardy soldiers. I guess the last 2 years has taught us something. Um, I want to hear from you all. If you go on our website or you go to LinkedIn, my information about how to get in touch with me is pretty easy. I keep an open calendar and am very interested in talking with all of you in your journey. If there's any way that I can support you, support your developers, that we can support you to build open source program offices or increase your security, please let us know. I think that there are white papers in the room, and I really want to draw your attention to both of the white papers. One of them is a case study of RTE and Oleander, two of our founding members, and one is a transmission system operator in France, and the other one is the largest distribution utility in the Netherlands. And it is a fascinating story about how they work together and how they have actually created a 10x factor on their development processes by working together. And that is the kind of speed that we need to move towards, and that really is my call to action, is we have to move faster. We are careening over the climate cliff. And the only way we're going to be able to do this is together. And we have to be secure, we have to be faster, cheaper, we have to be innovative, and we have to create communities actually that are based on trust, integrity, and really helping and supporting each other. And I love to see how this community, LF Energy, that went from just a couple of projects and a couple of members, is now at, I think, 64 members and 18 projects. And so, we are moving quickly. And then the final thing, if you really want to learn more about kind of how Europe, for instance, is thinking about digitalization, is the second paper. And that was our commentary to the European Commission, of which this paper really is going to be at the core of some of their recommendations about open source and the funding that they are funding, as part of their government processes. Those projects are coming into LF Energy because they see it as a process of R&D and then commercialization. So really interesting reads, and I think they're in the room. I think Russell was holding them up. I want to thank Z Prime. I want to thank the guys, the folks in the room who kept trying to get those reads correct. And of course, you all, I hope you have a good rest of the day. I hope you have really good barbecue and cocktails and whatever comes next.
Thank you.